find the integral of ln x dx by writing ln x as 1 times ln x. Hence, find the integral of ln x squared dx. So we're going to start with the first bit. So we're going to write the integral of ln x dx. Going to do exactly what we've been told to do, equals the integral of 1 times ln x dx. So the reason why we're doing this is so we can use integration by parts. Integration by parts, the formula is that the integral of uv dashed equals uv minus the integral of u dashed v. So we need to select a u and select a v dashed. So the u needs to be something that's easy to differentiate, and the v dash needs to be something that's easy to integrate. Now, you don't really have a choice, because say we selected the v dashed as ln x, then we're going to have to integrate ln x, but that's the whole question anyway, so you don't really have a choice. Plus, once you differentiate 1, it's just going to go to 0 anyway. So we've got to, ln x has got to be the thing we differentiate, so that's got to be the u, which means that the 1 has got to be the v dashed. So, little table, or little list of values, so u dashed, v dashed, u equals ln x. Standard derivative, ln x differentiates to 1 over x. V dashed is 1, and the integral of 1 with respect to x is just x. So they're all quite nice values. So now we have that the integral of ln x dx must be, well, it's uv, so ln x times x, we'll call that x ln x, minus the integral of u dashed v. So u dashed is 1 over x and v is x, so 1 over x times x with respect to x. So 1 over x times x is just 1. So the integral of 1 with respect to x is x. So this is equals x ln x minus x plus the constant of integration. So that is the first bit done. Remember, that's the integral of ln x, which we're going to use for the second bit, I imagine. So now, hence, find the integral of ln x squared dx. So we've kind of been giving a hint. What we're going to do is we're going to rewrite this one as ln x times ln x. So just put a line to separate. The integral of ln x squared with respect to x, we're going to say, well, that's the integral of ln x times ln x with respect to x, and we're going to do it by, we've got a product, we're going to do it by parts, and we can do it this time because our first part has led us to we actually do know the integral of this, and we already knew the derivative, so we can pick our u and v dashed because we know how to differentiate one and we know how to integrate the other. Well, they're both the same anyway. So u is going to be ln x. U dashed, we know that derivative of ln x is 1 over x. V dashed is ln x. So v must be the integral of that, which is x ln x minus x. Don't worry about the constant of integration. X ln x minus x. So now we can put it in. So this equals, so the integral of this, remember the by parts formula is uv, so ln x times x ln x minus x, so that's uv minus the integral of u dashed v. So u dashed is 1 over x times v is x ln x minus x with respect to x. So looks a bit daunting, but if you look at what's going to happen, it's going to tidy up really, really nicely. So I'm going to expand this bracket, so that x ln x times ln x is x ln x squared minus, well, then you've got x times ln x, which is just x ln x, minus, well, the integral of, if I distribute this 1 over x into there, so 1 over x times x ln x is just ln x, minus, well, 1 over x times x is minus 1 with respect to x. So we've got x ln x squared minus x ln x minus, well, the integral of ln x, which we have from before, is x ln x minus x, and then the integral of 1 with respect to x is x, so that must be, the integral of minus 1 must be minus x, and I actually think I might put minus x like that, plus the constant of integration. So then we've got a bit of tidying up to do. What you have, so you have this x ln x squared, final answer, equals x ln x squared, and then you've got minus x ln x minus another x ln x, so that must be minus 2x ln x, and then you've got, well, minus x is minus 2x times by the other minus there, that must be plus 2x, and then plus the constant of integration. So it's quite a long result, but you would not have been able to do that without using integration by parts. It's a very useful technique.